All right, guys, here we go, guys. You guys ready? Your first move, maybe immediately, once you have some experience, you'll be able to just go right into it. Your first move when you're going here, you got to know the first quadrant at the very minimum 0 degrees, 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. You at least got to know that. 0 radians, pi over 6, pi over 4, pi over 3. And then the very first, this is the unit circle has a radius of 1, so 1, 0. Then the x is larger than the y, so square root of 3 over 2, that's like 0.866. And then 1 half. And then at the 45 degrees, it's square root of 2 over 2, square root of 2 over 2. And then these toggle from the 30-degree one, so 1 half, and then square root of 3 over 2. And then finally 0, 1. Are we still okay? All right, and then if you wanted to continue, if you wanted to, this remains with the denominator of 3. It's just like the one in quadrant 1. In the top, you put 2 pi. You guys see what we did there? This one has a remainder of the denominator of 4. The bottom will be 3 pi. Denominator, I keep saying remainder. Denominator of 6, numerator 5 pi. And remember, don't be a robot. Look at the previous notes. Notes 3, it's because like this reference angle here is pi over 6. This is a pi. So you're 1/6 pi away from a whole pi if you were to do this. So that's why this is 5 pi over 6 at 150 degrees. Of course, you continue with the pattern. That's 90. This is 120. This is 135. Add 15 to 135, 150, 180. You don't have to continue it, but you can if you want. Cool or not cool? And then, I'll just continue with the radians at the very minimum. 7 pi over 6. The denominator here is a 4, so 5 pi over 4. The denominator here is a 3, so 4 pi over 3. Then you got to know this one. That's just 3/2 pi or 3 pi over 2. And then this one here, the denominator is still a 3. Double the denominator, subtract 1. So double of 3 is 6, subtract 1, 5, so 5 pi. The denominator on this one is a 4. Double the denominator, 8, subtract 1, so 7 pi. The denominator here is a 6. Double the denominator, 12, subtract 1, 11. If you don't know what I'm talking about, look at the previous notes, notes 3. And then 1 full revolution, 2 pi. Are we still okay? Okay. And then the coordinates, you just reflect them. I'll just do the one in quadrant 2 and then call it a day here. The x coordinates are negative, so negative half, comma, square root of 3 over 2. Negative square root of 2 over 2, square root of 2 over 2. And negative square root of 3 over 2 and 1 half. Are we okay? Okay. All right. Is it okay if I go now to the front page of this? Okay. I'll make another video. I'll make 2 videos. I'll make this one, how to tackle it, and then I'll make another one where I'm going slow. Okay. So you see cosine pi over 3. The first thing I'm thinking right off the bat is, oh, I'm in quadrant 1, and it wants the x coordinate at pi over 3. Yes, and then initially maybe you'll probably be referencing this, but once you're a pro, you won't no longer have to reference it. Here's pi over 3. The x coordinate is a half. And what am I talking about, Chop? What are you talking about? I'm going to go ahead and write it here just for notes. Guys, all of the 1s over 3 will always be a half. You just got to figure out whether it's positive or negative. So I'm going to put 2 pi over 3. I'm going to put cosine of 4 pi over 3. And I'm going to put, where did I put the other one? Over here. Cosine of 5 pi over 3. Okay, check it out. Cosine 2 pi over 3. You see the 2 pi over 3? You should be thinking quadrant 2 because it's cosine. It's the x coordinate. Oh, okay. In quadrant 2, the x coordinate is negative. Oh, this must be a negative half. Cosine 4 pi over 3, you think 4 pi over 3, you're like, oh, 4 pi over 3, that's quadrant 3 because the integer in the numerator is 1 more than the denominator. Oh, that's quadrant 3. Everything's negative in quadrant 3. Negative half. 5 pi over 3, oh, that's quadrant 4. Double the denominator minus 1. Cosine's the x value. In quadrant 4, x is always positive. Oh, this must be a 1 half. Do you see how I'm doing it, guys? Okay, so all you got to know is the first quadrant. And then from there, just use logic. See? So cosine 7 pi over 4. Okay, 7 pi over 4. What quadrant is that? I don't know. Fourth. Yeah, because double the denominator, subtract 1. No, it's okay. This is a safe space. Double the denominator, subtract 1. 7 pi over 4. Quadrant 4. In quadrant 4, is the x positive or negative? Positive. Square root of 2 over 2. Anything over 4, they're being nice to you. You don't have to do any thinking. It's always going to be square root of 2 over 2. You just got to figure out, is it the x or is it the y? And what quadrant you're in. Does that make sense? Tan of 2 pi over 3. Tan is y over x. 2 pi over 3 is in quadrant 2. Like I said in the beginning, you might have to reference it, but after a while, you're going to know it. like the back of your hand. So the y value at 2 power over 3 is square root of 3 over 2. The x value at 2 power over 3 is a negative 1/2. This is an okay answer. If you type that in, I'll put okay. I'll kind of correct. The better answer is negative square root of 3. Are you seeing how we're doing it, guys? Okay, sine 7 power over 6. You think 7 power over 6? Oh, I'm in quadrant 3. Everything's negative. Sine is the y value, negative 1/2. It's a 1 immediately. You pass the 180. It's a 210 1. Are we still okay, guys? All right, I go to 5 power over 3. You think, oh, 5 power over 3, where's that? Double the denominator, subtract 1. That's quadrant 4. It's a sine value. So negative square root of 3 over 2. Yes.
Why are you saying that it's a y value? Why is sine?
Okay, so from notes 3, when we did this, so here's my reference triangle or my grid, and then I did radius of 1, because remember, here's the circle like this. And then I went, here's my reference triangle, and I said that my horizontal displacement, this was an x, and my vertical displacement, that was a y. So this point way over there, that's an x comma y, right? And then we did this. Remember from the units from yesterday, that's my angle, so katoa. And then look, so y is cosine an x and sine a y. Sine is opposite over hypotenuse. Well, opposite of that angle is a y. Y divided by 1, OMG, y divided by 1 is just y. So then we said that sine of some angle is always your y. See? And then we said, what do we say for cosine? Cosine is adjacent over hypotenuse. There's my angle. Adjacent is x, hypotenuse is 1. So cosine of that angle is adjacent, x over 1. X divided by 1 is always x. So cosine from now on is just x. See? And then tangent of that angle is y over x. Do you remember that? Are we good? You're not just telling me that just to tell me that, right? Like you got it down? Okay. Sine of 11 power over 6. It says sine. We're going to get the y value. 11 power over 6. We're so close to a full revolution. Negative 1/2 because we're in quadrant 4 and it's a y value. Do you guys see how we're doing it, guys? Okay, tan 5 power over 6. That's quadrant 2. Y divided by x. By the way, guys, at 5 power over 6, your coordinate is negative square root of 3 over 2, comma, positive half. See? I know maybe right now you don't know it just yet, but all you got to do is focus on these. If you know that one at power over 6, then at 5 power over 6, the x is always negative. They're always the same. Well, the patterns. Does that make sense to you guys? Okay, so here we go. So tan of 5 power over 6 is y over x, 1/2 divided by a negative square root of 3 over 2. This is an okay answer. The better answer, I'm going to say better because there's another one, is a negative 1 over square root of 3. And then the best is rationalize it, multiply by square root of 3 over square root of 3, negative square root of 3 over 3. That's what delta math was going to take if you've been doing the delta math and it didn't take the negative 1 over square root of 3. It's because it wants it rationalized. All 3 of those, I'll count them correct. What are the habits of my kids, especially when they're first starting to learn it? The habits of my kids are to leave it like that. That's fine. I'm going to count it correct for now, of course. Later on, we're going to want better. That's the mirror. No yawning. No, miss, I'm kidding. So yeah, are we still okay? All right, cosine 4 power over 3. So you think 4 power over 3, you're like, oh, 4 power over 3. That's in quadrant 3. Everything's negative in quadrant 3. And because it's 4 power over 3 and it's cosine, that's going to be a negative half. See, I put it over here with that one. All right, sine pi over 6, that's at 30 degrees. Sine is a y value, that's going to be a positive half. Sine 3 pi over 4, 3 pi over 4 is quadrant 2. The y values in quadrant 2 are all positive. Square root of 2 over 2. All the ones over 4 are square root of 2 over 2. Or if it's a special angle, which they are. We're not going to try and trick you. 5 pi over 6, that's cosine, negative square root of 3 over 2. You're in quadrant 2 and the x value is negative. Is this helping, by the way? Going over it like, okay. Sine 5 pi over 6. Oh, did I ask that a question? I feel like I already asked it. No? Okay, I just, sine 5 pi over 6, 1/2. Oh, okay, these. I put these in there for my calculus kids, really. But don't worry, on Monday we're going to cover the reciprocal. Secant, do you remember what secant is the reciprocal of? No? Okay. Secant is the reciprocal of cosine. Let the first letter give you a hint. They just toggle. Secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. See? So that's a hack, quote unquote. See? So at 2 pi over 3, cosine is negative half. So negative 2. You just take the reciprocal. Do you see what we did there, guys? Yeah, I'll write it right here. Negative half, we take the reciprocal of this. So reciprocal, let me see if I can spell it correctly. Reciprocal of that is negative 2 over 1. You don't put the 1. You can if you want. It's not a big deal. Cosecant of 4 pi over 3. So cosecant is reciprocal of sine. 4 pi over 3 is in quadrant 3. Sine would have been negative 3 pi over 2. Negative 3 pi over 2. Negative square root of 3 over 2. Reciprocal, negative 2 over square root of 3. This is an okay answer. A better answer, negative 2 square root of 3 over 3. Or best. Do you guys see that? You could have also written, and I would have counted it right. Some kids do this. They just go 1 over negative square root of 3 over 2. Because sine is negative square root of 3 over 2. I guess this, I'll probably give you like an awkward emoji and put okay. Because that is correct. 1 over something means take reciprocal. Are we still okay? All right. Cotangent of pi over 2. Well, at pi over 2, that's 90 degrees. Remember, well, that's the reciprocal of tangent. This coordinate is 0, 1. Tangent would have been y divided by x, 1 over 0, which is undefined. But 0 over 1 is 0. So we're good. Maybe that one would have been a hard one, maybe. Does that make sense of how we did things? Did this make sense? Okay, we're going to have another quiz on Monday. The time, instead of 20 minutes, will probably be 15. Is that okay with you guys? Okay, don't worry. We're not going to lower it lower than, I think at the very end we go like 7 minutes, 8 minutes. But not until you guys are experienced. It is your first rodeo. All right. How much time we got? Oh, we don't got much time. All right, guys. Make sure to make an attempt on the UH quiz. And you do got some time, like 10 minutes. If you think you can do a few problems on Delta, go for it. If not, that's fine. And I'll upload this later on tonight.